I'm a machinist. I've been here for a little over 7 years. I started as a mechanical assembler building scissor lifts, and after 5 years of doing that, I came up and learned how to run the KBN machining, and I've been doing that for a little over 2 years now. It's going to drill 3 holes in this side of the part. We're running coolant with it because if not, it'll just melt the steel. When it's done drilling this hole, it's going to go do a tool change, and it's going to tap the hole. The programs are all pre-written, so once we have them proofed out, you don't really have to change anything. Here's a little bit of the programming. It's telling it to do a tool change. And then it's picking up offsets of where to take the next tool. With the programming, it picks up where it drilled the holes, so you just want to pay attention and make sure that it's going to tap the hole that it just drilled. I'm going to adjust the coolant so it's hitting more on the tap. You don't run coolant with a tap, it'll break pretty much instantly. Next tool change is the last tool it runs on these parts. Once again, a little bit of the programming. It's telling which tool to pick up, and then it gives its offsets again. Tells the location and what to turn the spindle on to. This tool is finishing the bores. It's a smooth finish, and that's what the pin will go through. There's other parts that we do on another line here that they go down inside of these turntables, and it hooks up to booms. It's a great big boom lift when it's all assembled. This tool is only taking out about 30 thousandths of an inch, so we don't run coolant with it. It's not cutting very much steel. Okay, it has to do the bores on the other side of the table, so it's going to back away and spin. This tool has an adjustment on it. When we check the bores, it has a certain tolerance. We have 4 thousandths tolerance in these bores, so I check it. I just set it so it's right in the middle of tolerance. So right here is the settings. There's a screw over here, and then each one of these is half a thousandth. You get it dialed in, and you can run for a good portion of the day. A little bit of the screen while it finishes turning there. Tells it what location to go to, and it'll turn the spindle on, and it'll take it in and start drilling the other holes. just going to do the same thing on the last one. Here's a little bit of our manual control panel. You can change the spindle speed, the feed rate, the rapid. You can put it in manual. These are the controls to run in manual. Over here you have in edits how you change from program to a different part. MDI's manual data input. There's memory, which that's what the stored programs are. And you have all these buttons over here, feed override. You don't mess with them when you have a preloaded program. A lot of times if you have a rework, that's you use them then. Now this part's completed. Okay, first thing is deburring all the holes that you bored. This is the most important thing about machining, is inspecting your parts. If you're not making good parts, then you shouldn't be making any. Okay, this is a tri-mic. It has 3 prongs you stick in. And I'm looking for a tolerance of 2.5 inches plus 6 to 10 thousandths. Right there I'm at 9 thousandths. I adjusted it and it's down to 7 thousandths. So that's 2507. And that one's 2508. 2507. So I'm right in tolerance. This is a thread gauge. You want to check and make sure that the holes you tap are the correct threads. And then you need to measure certain points of the part. The tolerance is 479 to 491. So 481. 482. 484, 482, 480, 482. You also want to pin check it and make sure that it'll pin up with the parts that it goes with. And the machining process is done.